Hi guys, and welcome to Module 16, where we will be talking about measures of center. In this first slide, we're talking about finding the mean, and the mean is the average. So in order to find the mean or the average, we have to add up all the data values and then divide them by the number of data values in the set. So for example, if we have this table with people who have been tallied and asked their number of siblings, we have 2 plus 3 plus 1 plus 1 plus 3. That is a total of 10. So the sum of the data values is 10 divided by the number of data values, which are 1, 2, 3, 4, 5. And so the mean or the average is 2. In order to find the median, we would have to order the data set from least to greatest, and then the median represents the middle value or the middle guy. So for example, in this data set, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 values. And make sure that when you order them from least to greatest, you do count them and make sure that they match up. We have 11 data values in the set, and what we can do is cross out the little guy with the big guy, little guy, big guy, little guy, big guy, little guy, big guy, little guy, big guy. That guy in the middle, that guy in the center, he is the median. Now what happens when we write the data values in order from least to greatest and we have two middle values left? So we cross out little guy, big guy, little guy, big guy, little guy, big guy, little guy, big guy, and we're left with two numbers. What we do is we find the average of those two values. So you would take 87 plus 90 divided by 2, and the median would be 88.5. When we compare the mean and the median, sometimes the mean and the median are very close to each other. They may be equal or they may be very different. For data sets where the mean and the median are very different, one likely describes the data set better than the other. So let's see an example of when one is a better value to describe the situation than the other. So if we have monthly earnings of several teenagers to be 200, 320, 275, 250, 750, 350, and 310, we talked about that 750 being an outlier. He is very different than the rest and will affect the mean. When we find the mean, we are going to take the sum of all of these, which would be 2,455. And we would divide that by 1, 2, 3, 4, 5, 6, 7 numbers in the set. So that would be a mean of $350 and about 71 cents. So let's just round that to 351. The median would be order them from least to greatest. So let's do that. 200. 250, 275, 310, 320, 350, and lastly 750. We make sure that there's 7, 1, 2, 3, 4, 5, 6, 7, and median means you cross out little guy, big guy, little guy, big guy, little guy, big guy, and so the median is $310. The mean and the median differ by about, 351 minus 310 is about $41, so approximately $40 difference between the mean and the median. So which measure of center best describes the typical monthly earnings for this group of teenagers? It would be the median, because 310 is a closer value to all the other numbers in this data set. So, for example, if we said that the mean was a better describer, a lot of these teenagers would go ahead and make anything close to $350. This one made only $200. This one made only $275. He made $250. He made $320. So they all made less than the mean, except for this one also made less than the mean, the 310. So there's only two data values that are greater than or equal to the mean. So the one that describes best this data set would be the median, because he's closer in value to all the other numbers or values in this data set. When we calculate the MAD, that is talking about the mean of the distances between the data values and the mean of the data set. Remember, the way you're going to remember how to calculate mean absolute deviation is it makes you mad that you have to calculate the mean twice. So the first thing we have to do to find the mean absolute deviation is we have to find the mean or the average of the entire data set. So we would take these numbers and we would add them all together, getting a sum of 591. We would divide it by however many numbers there are in the set, 5, 6, 7, 8, 9, 10. And so we get 59.1. We're going to round that to the nearest whole number, so that's about 59. We're going to do something with this mean in order, on the next slide, to calculate the mean absolute deviation. Now remember, the mean was 59. So we're going to take 59 and we're going to compare it to the other data values. So that's going to give us the difference or the distance from the mean. So to get on the number line from 59 to 60 is a difference of 1. 58 to 59, difference of 1. 54 to 59, difference of 5. 56 to 59, difference of 3. 59, 60, 61, 62, 63, that's 4. 59 to 65 is 6. 59 to 62, 59, 60, 61, 62 is 3. This is 0, this is 3, and this is 1. So now the last step would be to find the mean of the distances. So we would add the 1 plus 1 plus 5 plus 3 plus 4 plus 6 plus 3 plus 0 plus 3 plus 1. Let's go ahead and add that. That's 2, 7, 10, 20, 3, 26, 27 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data values. This is going to be 2.7, or we're going to round that to the nearest whole number, which is a MAD of 3. And we went ahead and did all the work on the previous slide. Remember, the sum of the distances was 27, and we divided by 10, which was the values in the data set. And so the mean absolute deviation was 2.7, which we rounded to the nearest whole number. And so the MAD was 3. When we are using a box plot, this displays how the values in a data set are distributed or spread out. When creating a box plot, you have to first find 5 values that are essential for the box plot. The least value, the lower quartile, the median, the upper quartile, and the greatest value. We talked about in class how this one, the least value, was simple. We understood that. The median, we already knew how to calculate the middle guy, and the greatest value. So we talked about what the upper quartile and the lower quartile was referring to. Remember, once you cut your data value in half, the lower quartile is going to be the median of the lower half of the data set. And then the upper quartile is going to be the median of the upper half of your data set. So your second step is to draw the box plot. And when you draw your box plot, you're going to draw a line segment connecting the least value to the lower quartile. You're going to draw a line segment connecting the upper quartile to your greatest value. You're going to draw a box whose ends pass through the lower quartile to the upper quartile, and then you're going to draw a vertical segment on your median. We talked about finding the interquartile range, and remember, the interquartile IQR is the difference between the upper quartile and the lower quartile. Inter meaning between, so you're really finding the distance between your lower quartile and your upper quartile. So these are two different groups, and to practice finding the IQR, we take let's just look at, and let's focus on group A. First, we look at the upper quartile, and that one is at 24. minus the lower quartile, and that is at 20. So the IQR for Group A would be 4. We do the very same thing for Group B. And Group B, the upper quartile is 26. The lower quartile is 21.5. And so our IQR there is 4.5. Remember, IQR refers to interquartile, so meaning what is between the lower and the upper quartiles. When we are finding the range is easy. We learned in class to write range like this with a really big R and then a really small e, because the range is the difference between your greatest value minus your lowest value in the data set. So they might give you a very long set of data, and that's okay because you're really just looking for the range. You're going to order least to greatest, and the reason that you do that, let's just take a look at Team A, for example. The reason that we order them from least to greatest is so that you can have your greatest value, 39, minus your least value, which is 21, and so the range is 18. For Team B, we would do the same thing, order from least to greatest. That way we see the big guy is 31, the little guy is 21, and so our range for Team B is 10. We also talked about what happens if you are given the mean and then you have to find one of the missing values. So this is telling us that the mean is 13, and we have 5 values of which we have to find the missing one. So what we're going to do is we're going to take the mean, we're going to multiply it by the values in the set, which is 65. That means that all of these numbers have to add up to 65. So we can take 65 and start subtracting these, and that'll give us the missing value. Or we can add 12, 16, 14, and 8. That gives us a total of 8. That's 20. 2, 3, 4. That's 50. So what we could do is take the mean, subtract it by the values that we already have, and that missing value is 15. We talked about statistical questions being questions that have many different or variable answers. So it's something that you can create a data set from. So we talked about certain situations that could yield variable data, meaning it is a statistical question if we can get many different answers. For example, the typical weight for an adult cat is a variable. We could get many different answers for that. Car owner wants to know how much money people, so we're asking more than one person for sure, that's going to be a statistical question, pay for a new tire. Some examples of not statistical questions. You want to know how tall your friend is. And the reason this is not is because you're just talking about one person. My friend is only inches or feet tall. You want to know how far your house is from school. Again, we're only talking about one, and so that is not statistical. And lastly, how many students were in line for lunch at the cafeteria today at the specific time. That only yields one answer. When we make a dot plot, it is a visual display in which each piece of data is represented by a dot, and the dot plot shows frequency of each data value. So for example, if we have this manager who records the number of runs scored by the team in each game, and we use this information to make a dot plot, these are the runs that were made, and so we're going to make a number line. And we're going to name this runs scored. We're going to draw a dot above each number line for each data value. So 0, no run was scored in this game, so there's only one dot there. Where 1 run was scored is 2, 3 times, so we draw 3 dots there. 2 runs scored, 1, 2, 3, 4, 5, 6. We have 6 dots there. 3 runs scored, we have 1, 2, 3. There are the 3 dots there. Where 4 runs were scored, we have 2 there. 5, we only have 1. 6, we only have 1. 7, we only have 1. And 11 seems to be the outlier because he is much greater, and typically, normally, they're not scoring that many runs per game. We can answer questions based on this dot plot. For example, how many games did the team play during the season? We can tell by looking at the dot plot, we can count the scores that were, the runs that were scored for each game. So all we have to do pretty much is count the dots, and that will tell us how many games the team played during the season. So 1 plus 3 is 4, 5, 6, 7, 8, 9, 10, 13, 15, 16, 17, 18, 19 games were played. And how many games did the team score 2 runs or fewer? So we're really just looking at this part right here of our dot plot distribution. So 6, 7, 8, 9, the answer here is 10 because we look at 2 runs scored or less. Interpreting a dot plot gives us a visual picture of the spread, how the data is spread out, the center and shape of the data distribution. So we learned about outliers. They are the values that are either much greater or much less than the other data values. They're typically very off by themselves, and I told you guys that I remembered it by saying outlier, and so they're typically out by themselves. We also learned about peaks. When we think about peaks, we think about mountain peaks, so it's the highest point in your dot distribution. Your clusters are the ones that are clumped together. So from what number to what number is the information clustered or clumped together. Symmetry means a symmetric distribution has approximately the same number of data values on either side of the center. Typically, we think about symmetric being exactly the same. When we talk about a dot plot, we want it to be approximately the same number. So if we folded this dot distribution or dot plot in half, or if we cut it in half, would it look balanced on both sides? That would be symmetrical. So describing the spread, center, and shape of this data distribution, the spread means where does the dot plot start and where does it end. So the spread is from 3 to 7. It has no outliers because everything is clustered together. From 3 to 7. The peak is at 5, which is the center of the distribution. It is symmetric because if we folded this in half, it pretty much looks balanced on both sides. Looking at another example, the data values are spread out from, so the spread is 1 to 9. The data value 1 appears to be the outlier. He's the one off by himself. The cluster is from 6 to 9. That's where they're bunched together. The peak is at 9, and it does not appear to be symmetric. Remember, we read from the tail, so this is a skewed left distribution because the tail is on the left. We can also find measures from a dot plot. In this example, again, we have the number of runs that were scored by a baseball team. We put that in a dot plot, and so the data distribution shows ranging from 0 all the way to 11. To find the mean, we again would have to find the sum of the data values, and so we would add 0 plus, and this is important because what we would do here to find the mean, I'm going to go ahead and put 1 here, the mean, is we would add all the different dots. So we have 1 0, we have 3 1s, we have 6 2s, we have 3 3s, we have 2 4s, we have 1 5, 1 6, 1 7, and 1 11. So we would add all that together and then divide by however many values there are in that set, and there are 19. So you would take the sum of this, which is 61, divided by, there's 19 dots, and that's approximately 3.2. So the average is about 3 2/10. To find the median, we would go ahead and leave it just like this, where it's least to greatest. We would cancel out little guy, big guy, 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 and the median is 2. He's the middle guy. To find the range, we would take the highest value subtracted by the lowest value, and 11 minus 0 is 11. So the range would be 11. A histogram is a type of bar graph whose bars represent the frequencies of numeric data within intervals. So we talked about this example where we have the bird watcher. He was counting and recording the number of birds that he saw every morning at 9 for several days. So these here are the number of birds that he saw. And remember, to make a histogram, you would always have to make a frequency table first. We talked about how the frequency table has intervals and frequencies. So intervals are going to be based on your data values in the set. In this case, we are ranging from 1 to about 16. So we can count by fours. We have an interval of 1 to 4. He saw between 1 and 4 birds 8 times. He saw between 5 and 8 birds 4 times. He saw between 9 and 12 birds 2 times, and he saw between 13 and 16 birds 1 time. When we make the histogram, we want to make sure that the intervals are listed on your x-axis, and your frequency is always on your y-axis. We talked about how the bars have equal widths. One is not a skinny little bar, and the other one is going to be a fat bar. And they should touch your bars, but not overlap. And so when you make your histogram, you would go ahead and put your intervals on your x-axis, the frequency on the y-axis. And here we represent all the information that was on the table. 1 to 4 birds 8 times, 5 to 8 birds 4 times, 9 to 12 birds 2 times, and 13 to 16 1 time. This concludes our review of Module 16. If you have any questions, please feel free to ask.